All right, example 5. Here we have a car moving at 24 meters per second. It strikes a stationary car of the same mass. Both of them are 1,500 kilograms. They collide, they stick together, and slide together for 2/100ths of a second. The coefficient of sliding friction is given as mu equal to 0.9. Now, so this is a perfectly inelastic collision. They stick together. So, how much does the friction force change the momentum of the system? And how much does the friction force change the velocity of the cars after impact? Remember, the cars are moving as a single unit after impact. So, let's attack part A. So, friction force. That's mu mg. Right now, m is the total mass of the system because this is an inelastic collision. So it's m1 plus m2, and that's 1,500 plus 1,500 equals 3,000 kilograms. So we have all these. So the force of friction then is going to equal 0.9 times 3,000 kilograms times 9.81 meters per second squared. And that gives us 2.64 times 10 to the 4th newtons. Okay, so how does that translate into a change of momentum? All right, well, remember from the last problem, right? Now, last time we had to integrate this because f was a function of t. This time we're assuming, we're not told anything different. We're being told that there's a coefficient of friction and there's a frictional force. So we're going to assume that f is constant. All right, it stays the same with time. So that means we don't have to do integration. We can just make this a delta p, a change in p, is that frictional force times the amount of time over which that force acted. So the change in momentum then is just the force, 2.64 times 10 to the 4th, times the amount of time over which it acted. So we get 530 kilogram meters per second for the change in momentum. Now for the second part of that, we know the change in momentum is mass times change in velocity. Now we know mass isn't changing. This is what we're looking for. So delta V is the change in momentum over the mass. We just found the change in momentum, 530 kilogram meters per second, and the mass didn't change, that stays constant. So the change in velocity due to the frictional force is 0.18 meters per second.